Welcome to Entangled Health, where we explore the intersections of quantum science, AI, biotechnology, and human well-being. My name is Thomas, and I'm convinced that health innovation happens at the entangled boundaries, where cutting-edge physics meets biology, where consciousness research intersects with technology, and where visionary thinking transforms into practical solutions. We bring together pioneers, researchers, and innovators who are reshaping how we understand and experience health. My guest today is Gabriela Cimpan, who is doing technical business development at Quantinuum, one of the largest quantum computing companies worldwide, where she helps bridge the world of quantum hardware with real-world biotech innovation. Her journey spans academia, analytical chemistry, and engineering, all the way to the front lines of quantum computing for healthcare. Gabriela's work focuses on turning complex quantum theory into practical tools for drug discovery and molecular modeling, while championing ethical tech and mentoring the next generation of quantum leaders. We will be talking about what entangled health means at the intersection of science, technology, and human well-being, how her unconventional path shaped her approach, and why collaboration and mentorship are non-negotiable in this space. A quick disclaimer, the dialogues on Entangled Health are a co-creation between the guest and myself, which means also today's chat is not an official statement from our industries. Gabriela is here in a personal capacity, as am I, so everything we share is just our own take, not the official view of Quantinuum or Merck or any other organization. To add a little bit of dopamine, later in the show we'll dive into the Entangled Health question pool, where curiosity lives in Hilbert space. And here's how this works. 1. You submit a question via LinkedIn or episode comments. 1 per listener, keep it spicy. 2. A quantum algorithm running on real hardware picks which one we answer. And 3rd, our guests add their own question to the pool and then answered it live. The rules for now, it's quite simple. Ask anything. The guest might decline, but where's the fun in playing safe? And if you reach 1 million listeners, we might change the rules, but that's a bit far out. Stay tuned, and who knows what the quantum dice will reveal. Yeah, Gabriela, so this is so cool to have you. And you were the first I asked if you would like to be my guest on this new show, and you immediately say yes, so thanks for that. And while the universe was a bit quicker in finding time slots with other guests without so much review cycles, no, just kidding. You're actually the very first guest from the quantum industry. And even a quantum computing company on this new series. And I think this is pretty special because it gives not just this, let's be friendly, but it's the industry also talking to each other. I think that's quite cool. Before we dive into your work, for our listeners, new old listeners, the idea of the podcast is really to bring people together that should know of each other. Or I think that the best way is then always to start at the beginning and the journey, if you want. But before that, I'm always keen to learn from my guests what the initial take from you, Gabriela, was on Entangled Health. So can you just share what went through your head the first time I reached out?
Hi, Thomas. Thank you so much for inviting me. Entangled Health. It's an intriguing name, isn't it? It brings to mind overlapping and intercorrelated fields. And also, what is entangled? So I looked it up. According to the Oxford Dictionary, it means caused to become twisted together with or caught in. So I can imagine overlapping and interdependent scientific fields, a nice colored graph, if you may. Mm-hmm. But then if you ask what is entangled, we can also ask what is health. So I looked this up as well. Okay. As defined by the World Health Organization, who, I quote, in inverted commas, is a state of complete physical, mental, and social well-being, and not merely the absence of disease or infirmity. This definition emphasizes that health is more than just the absence of illness. It encompasses a positive state of being across multiple dimensions. Wow, this is a mouthful. So yes. we don't tend to think too much about health when we have it. But then when things start to go wrong, we want to understand why. We are unique individuals, but we also share a large part of our core structure. Mm-hmm. So as an individual, you want to know what common causes make disease develop, what from our unique makeup contributes, what from our external environment contributes,
Mm-hmm.
what can help heal with or without external helping agents.
Mm-hmm.
And this is a hugely difficult problem to solve, mathematically difficult. There are so many parameters to take into consideration. It's a huge number, which most of the time we can quantify and analyze individuals. But then if you take into consideration the interdependency influenced by different factors, genetics, environment, the choices we make, you might say that we are entangled.
This is, cool. So I mean, there are a lot of topics. I guess we need to do several episodes with you then. So, so the idea of this podcast is initially, and I think we touch it later, where you were one of the reasons I did this, is to bring people together from different disciplines, so who work in different domains. You just shared. I mean, the definition, even the definition of health is so wide. Everyone shares a passion for one, or maybe all. Let's call these entangled topics: health, quantum, AI, art, consciousness, what have it. And most of us have a rather, let's say, unconventional or not really straightforward career path because it's just new. So there is no classical education that you could just take to land here in this widely undefined field. So if I recall correct, your path was academia. I guess you did analytical chemistry, some engineering, and now quantum computing. So, and if I'm not wrong, I recall that you mentioned that in high school you had noticed that the peers have been split between wanting to be doctors or coders. And as you mentioned this, and also the emphasis on the or, did that shape your journey? Can you walk us a bit through that?
Your memory is great, Thomas. This is always a topic with it's always a topic with many possible answers. What is my journey? I suppose I see it now as a journey, but I didn't see it as such at the time. So everyone has many choices in their careers, also in their life. You choose one, then you choose another one, so you build a journey. So looking back, I was always interested to know. I was interested in knowledge. Some people might say that sometimes I know too much about certain things.
Well, the downside of being intelligent.
And I was interested to understand the implication of that knowledge. So you make career choices during your journey, but you also need a bit of luck. And from that point of view, I consider myself lucky to have such inspirational teachers and mentors throughout my school and academic years, sometimes during my profession, and also through my various sports activities. As you know, I grew up in Romania, and I vividly remember my first art teacher. He was a Greek refugee who arrived in the 70s during the political instability in Greece, but then stayed in the country for many years. I believe he now went back to his home. But at the time, as many young girls have done, I had a booklet where people I liked could leave thoughts, drawings, and anything else they wanted me to remember about them when we grow up. I still have that book.
Good.
He wrote a simple statement. He didn't draw anything. Also, he was an art teacher, but didn't draw anything. He just wrote a simple statement. Put a bit of passion in everything you do, and you will succeed. And it stayed with me. So since then, I put heart and soul in everything I did. Some people may disagree today and say a job is just a job. You need to maintain your distance. But I think that if you really want to get to your goals, you have to put a bit of heart and soul in the game. For me, it's easy. It comes naturally, but it also uses more energy. And sometimes I may take things personally. I'll let the audience decide. Is this good? Not so good? Maybe that's why I'm not in the medical profession. And to come back to your question, I'm not a coder either. This is where the rebellious streak shows. None of my colleagues wanted to do chemistry at the time, so I did.
Who wants to do chemistry? I did. By the way, I dropped chemistry, and now I'm working in this industry. Maybe I should.
Lovely.
Maybe I should know some chemistry, but there are other people who have much more competence. And it's just I like that you mentioned live your dream or follow your passion, and I just noticed this with this podcast. So this is what I'm doing as hobby. I'm working till morning in the 4, but it's giving back energy. So I think it steals energy. I mean, it takes energy, but a lot of things come back. So
absolutely, you're totally right. Yes.
Yeah. And I mean, I was a bit inspired, and Chris, you might not want to be exposed for this, but I was again inspired from Chris Bishop, who is a wonderful person to do this podcast alone, not with him together. And what I like from him, learning from the best, he always asked the question if there have been some specific moments or pivotal moments or chance encounters in your life on top of what your teacher mentioned as inspiration that were kind of a turning point that make you think, now this is where I belong. I mean,
you mentioned Chris, so I had the occasion to talk to Chris many times, and I just love the way he looks at the conversation in itself. It's just wonderful to listen to him. He's a wonderful speaker. So turning points, major turning points, probably not, just went along with the flow. But as I said, my background is chemistry, and I have a degree in chemical engineering and a PhD in analytical chemistry. So lab and maths converge. Throughout my career, I collaborated with life sciences researchers and thought leaders, with the academic groups as well, with people from industry. I'm connected on LinkedIn with a large group of people as well, and I keep in touch with many of them. So I had a chance to learn about drivers in various environments. What drives academic research? What drives revenue-generating environments? And you just learn that constraints are everywhere. Everyone has constraints. Most of the time they're financial, but most of the time also everyone has to deliver something. So during the pandemic, an opportunity arose to join this emerging quantum computing field. So coming from my chemistry background, I could see the fascinating challenges and promises. So I joined Cambridge Quantum Computing, a British company, which in 2021 merged with Honeywell Quantum Solution, which at the time was a spin-off, the larger company Honeywell. They were building a quantum computer, quantum hardware, and long story short, this is how Quantinuum was born.
Yeah, this is in itself an interesting story. So we made a third series then maybe. And I mean, it's really interesting that you mentioned that the pandemic was transformative, and I guess it was transformative for everyone on the world in so many different ways. But specifically for this quantum, let's say, ecosystem, it was also a turning point for me because I recall when I first dared to speak publicly. Embarrassing myself to speak on panels, on quantum conference panels. And of course, this is much more easy to speak on these panels and on the need side of the industry, even if we don't exactly know what this meant back then. If you don't have to travel. So it's just you dial in and then you're here. So it's also much cheaper for everyone. And I also did internal upskilling. So I was embarrassing. I can share this with you. I'm not sure if you know. I was embarrassing myself back then when everybody was in home office to even go to our CTO and say, if you, and the innovator community, if you want, I can make a lecture on everything you ever wanted to know about quantum computing. And unfortunately, or fortunately, he said yes. Which put me a bit under pressure. So I worked for 4 weeks nonstop to prepare this 360-degree or in quantum plus 2 pi, so the Bloch-sphere talk. Yeah, and I mean it was very early days, and I think this was then when like people like Honeywell, they were developing stuff based on what they had in their basement, and came up with stuff, and people were exploring early versions of quantum computing and learning from the academia. And now looking back, so this was 4 or 5 years. And I think if we look today, this is fascinating what happened. So can you tell me a bit more? So from this belonging to the part of Cambridge Quantum and then now the merger, what are you doing in this more maybe hardware business or software business? So what's exactly your role? I mean, without going into sharing non-confidential topics also, but just something that your daily life works or what surprises you.
Sure, that was an interesting time, and yes, you're totally right. It was transformative and changing as well. So yes, I currently work for Quantinuum in a technical business development role. Quantinuum, for people in the audience who don't know this, is the world-leading quantum computing company developing quantum hardware based on trapped ions technology, as well as software. And here I can mention an open source SDK, which stands for Software Development Kit. We call it TKIT. It's spelled TKET. Middleware, which is an orchestration software platform called Nexus, and then quantum algorithms for the applications of the future, spanning a wide range of research topics from quantum chemistry to quantum AI and cybersecurity. I guess we will be able to share links in the podcast for people
definitely.
who would be interested.
We share hundreds of links.
In my role, I work closely with customers from various industries. So it's not only the pharmaceutical, the health industry, life sciences, but other industries as well. And it's fascinating to learn about their work and help make the connection with quantum computing. They're not quantum scientists most of the time, so they want to understand where their expertise can connect with quantum computing. So I learn something new almost every day, which makes it exciting.
This is cool that you also are touching not only one industry, because I think there is the tendency of the industry being a bit industry blind. So everybody is in their bubble, and then I think this is what we have in Germany. In Germany, we did generate this QTAG organization where we have people participants from different industries also sharing their problems and approaches that we think we might eventually touch with quantum computing. And we all have this, and I think you even more as a service provider, we hit these inevitable roadblocks when bridging quantum researchers like you guys or technology with the other side of needs. And then I call it always an interesting dance, depending on which side of the fence you're sitting. I mean, we all have to speak a different language or share what this is about and why people should be interested. So do you have a strategy or so that could...
So it is a dance. Shall I stand up and dance?
Yeah, maybe next time we do a video, yes, let's do that.
Yes, interesting question. So in my view, one of the biggest challenges in the quantum ecosystem is understanding what is real today. What can be done in the future, near future, but also long term. What is presented perhaps in an over positive light, what is possible and when is possible. There is so much information released every day. So everywhere you look, newsletters, LinkedIn, media, there is a lot of information. This means hours of reading and understanding and then assessing this information. And you can't do it alone. It's important to talk to people with different expertise and experience. So a lot of my time is spent talking to people. It's spent reading as well, but also talking to people. So when you understand this information, you also have to select what is relevant to you. I think that understanding the whole quantum ecosystem is possible, but it's not a simple task. It's not trivial. And to be honest, most of the time it's not even necessary. So once you establish an area of interest, look at what has been promised now and what has been promised in the past. Was it delivered or just promised? This is important. And I will underline that this is very important, actually.
And I mean, I think there are few companies who have, I mean, not few, there are some companies among Quantinuum who really have delivered. I mean, you see that people, I mean, a lot of startups come and have ideas and then they just fade away. But I think that there are some that really deliver and also are part really deeply embedded in the ecosystem. So maybe let's shift a bit gears on ecosystem, the impact on let's say future tech impact. So the quantum computing, AI reshaping. Maybe let's stick with healthcare in the next 5 to 10 years. And before going that, staying up to date, out of curiosity, I think I'm trying to play with all these AI agents that try to read news, and I have them as a chatbot to stay up to date. But I think maybe can confirm that you still need to read the stuff yourself?
Yeah, so I was thinking actually this morning, just before this podcast, I was thinking how the use of AI agents like ChatGPT can complement what you're actually thinking. Because somebody very wise told me a while ago that you don't actually learn anything going to university. It doesn't stay with you unless you really work into a certain domain. So I should rephrase the anything. You do learn stuff, but most of it doesn't stay with you unless you work in that domain. So what you actually learn at university is how to find information and how to continue learning and where to find that information. And it creates a process that then you can apply in different domains. And it is important. So now we have ChatGPT. We learn, our brain is accustomed to a learning process. How do you use the AI agents to enhance this, to enhance it rather than stealing away from you, from the thought process? And I think it can be done.
Yeah, me too. Okay, good. At least we agree. We agree that it could be done if we are disciplined enough and not outsource every other thing. Yeah, but let's maybe park that thought. I have in the podcast earlier, because we had taken a bit of time, so I have had some guests, and we have mainly focused on quantum sensing in the early episodes. And the link maybe also how this works with classical machine learning, etc., etc. And I think several discussions with you on a panel or after conference, there is an idea to go bringing quantum computing and quantum AI, whatever you mentioned, quantum AI, maybe generative AI with quantum or what have you. Is there something you can share on this topic?
Yes, definitely. I would say quantum computing and AI, they work hand in hand. AI is very good when it needs to improve speed, accuracy, the ability to learn from large amounts of data. And AI has many applications in the pharmaceutical industry, in the life sciences world generally. So you're looking at drug discovery and development, precision medicine, clinical trials optimization, manufacturing, like regulatory, commercial, and many others. Now, to be honest, my interest is mainly with the first three: drug discovery and development, precision medicine, and clinical trials optimization. So in the health-related part. And quantum computing has the potential to enhance AI beyond the current limitations of classical computing. So the concept of generative quantum AI, we call it GenQAI, is based on a simple but powerful idea. Combine the unique capabilities of quantum hardware with the flexibility and intelligence of AI. In simple words, I'm imagining a loop. So you create this loop, you use AI data, then use quantum circuits to generate more data, then use AI to learn from it and generate additional data. So this can be a very powerful feedback loop because the QPU, the quantum processing unit, creates new data. It's not data borrowed from some other source and repurposed, it's new data. And sometimes this new data is very difficult, maybe impossible to produce classically. So this can be very, very powerful, and it has the potential to enable breakthroughs in different fields.
So, yes, tell me. I think the challenge is always to convince the so-called naysayers, or maybe better phrase, the constructive critical. And I have my friends, and I think they are listening to this, so I don't name you, but you know who you are, who want to believe, but cannot yet. So asking for this friend, can you give a concrete example eventually on this generative QAI, what you're thinking of?
Yes, I can give several examples, but probably the one I'm more familiar with is an example coming from chemistry, because it's my background.
Yeah, go with that.
One of the most difficult challenges in quantum chemistry and material science is computing the properties of a molecule's ground state. And that's a scientific term. So I'm going to explain. The ground state is the quantum state of a molecule where all electrons occupy the lowest possible energy levels. So you imagine the molecule, you have all these electrons dancing, and then you imagine them in the lowest possible resting energy level. So in other words, it's the most stable configuration of a molecule. And calculating the energy of this state is the holy grail for designing new molecules, for new materials, for new medicine. And it sounds simple, but it really isn't. So calculating a value for this ground state of a molecule is an incredibly difficult task. Classical computing can cope with simple molecular systems, but for anything else, you need to make approximations. You need to cut corners, because otherwise you can't calculate. And you may ask, or the audience may ask, why do we need this ground state value? Why is it so important? Well, it is important, and it's critically important because it serves as the starting point for understanding almost everything we need to know about a molecule. It could be physical properties, chemical properties, biological behavior. So to give you an example, it's the chemical stability and reactivity, spectroscopy, understanding its relationship with other molecules. This is crucial for drug design, by the way, and for the creation of new,
nutrition
new materials.
And so much more for life
nutrition
itself.
as well. Absolutely. And also nutrition comes in in the next one I wanted to mention, understanding the biological function of enzymes, proteins, DNA, and many, many others. So that's why everybody wants to calculate that ground state. And quantum computing can help do that. When the quantum computers will have the capacity to deal with larger molecules.
Good. Tell me. Are we talking about Schrödinger or solving equations or...
Yes. So to solve this problem, and I'm going to mention again a term that may not be familiar to everybody in the audience, you're talking about an equation called the Schrödinger equation, which describes how electrons behave in a molecule. It's a mathematical equation, and it's difficult to solve because as you increase the number of electronic configurations, the scale exponentially increases with the number of electrons and orbitals. So you have a small molecule, let's say you have 5 atoms, and then you want to move to 6, 7, 10 atoms. The calculation increases exponentially, and it reaches a stage where you can't calculate it classically. So today, even powerful supercomputers can't solve medium-sized molecules exactly. But quantum computers, they work differently. They can naturally simulate quantum systems because qubits can represent superposition of quantum states, and quantum gates can mimic electron interactions directly. So I can see that this explanation becomes very technical now. So let me say, for those in the audience who are not familiar with quantum computing, that a qubit is a quantum bit. This is the shortcut to the quantum bit. And a quantum gate is a basic operation on one or more qubits. And let's leave it here for now.
Yeah, let's leave it here for now. But I was, when I was doing, I mentioned earlier this all you ever wanted to know and never dared to ask. I sometimes use the Death Star for a qubit, because the qubit, in principle, the probability you get to measure either a yes or a no answer is depending on where your laser point of the Death Star is pointing to, and the objective of quantum computing is rotating all these lasers that will produce a interesting answer. But yeah, good. And I think the challenge of building qubits for calculation is, I think listeners might have heard of, that you must not measure because the measurement is destroying the state of the qubit. So there's a very, very interesting, independent of Schrödinger's cat, which I don't like. There's a link to a Stern-Gerlach experiment where they first detected that nature is behaving completely different than we were expecting. And I think I will just put down the link and we'll stop here because we're not an educational session. But so what I wanted to say, this means spins are, or these quantum states are very difficult to control for computing because we must isolate them from the outside world. But on the other hand, this makes them perfect sensors because they can sense very weak magnetic fields. And there's the idea of the, I'm going to brag a bit, but there's the idea of the ecosystem going to crack quantum biology in the widest sense. I just recently had Clarisse D'Aiello. She mentions always there's quantum 4 bio, which means we use sensors, whatever, to detect better quantum information that we, and this will be the question for you, to understand, can we have better sensors for producing even more data, or even quantum in biology? Could we directly influence this? But let's park that. So I think the is there something for saying if we produce more quantum data, so if these sensors can produce quantum data, can we maybe complement the existing calculations methods with quantum simulations or I don't know.
Yes, it's a fascinating question, and you mentioned quantum sensing, which again, it's a very, very interesting field which progresses really fast these days. It's not currently part of my work focus, so my knowledge on this is a little bit anecdotal.
Okay.
But I do read and talk to people when open pioneering paths in this field. So I talked to a few people who were also guests on your podcast. And quantum sensing definitely already has promising applications in medicine and in biotech, but there is so much we still don't know, or I still don't know as well. So it's a don't know in general, scientific field, and it's don't know at personal level as well. So I'm eagerly waiting for scientific news. And here is the paradox for the field. The more we know, the more we understand that what we don't know is still a big part. So scientifically, we solve a problem and we open the door to many other questions with currently unknown answers. And I also notice part of the paradox that people who don't know tend to have the strongest opinions. So I'll leave this here. So I won't develop this topic for now.
It's rather these philosophical topics, or those who are most convinced just are those that don't know. Yeah, and I think that's always good to have this beginner's mindset, so to say. We always know that there's light at the end of this tunnel, and this might lead us to another one. So let's maybe just come back to a bit of more productive use, because we're talking industry. So the critical challenges in biotech or healthcare or other industries, but maybe focus on where we started with health or health-related industries. What's the one critical challenge that you believe that quantum computing could help solve, and how Quantinuum is working on that to make that happen?
Yes, one critical challenge is there are so many challenges in this field. And looking at how a drug, for example, medicine comes to the market, just following this process, this thought process. It starts with drug design and development. It goes into drug delivery, perhaps new mechanism, new material for delivery. It goes into precision or personalized medicine, whichever you prefer as a term. And then it is going to the big omics, like genomics, proteomics, transcriptomics, metabolomics, and there might be more omics. So humans are complex biological entities. On one hand, we have vast knowledge of understanding our building blocks, how they function and define us as human beings. But then, if you think on the other hand, there is still so much we don't know, and understanding how these building blocks live, and I put live in inverted commas because they don't live independently, but they have a life on their own sometimes. So today we have the capability to collect and generate vast amounts of data. So understanding it holds the key to solve some of the unknowns and forge new paths. So to answer your questions, is quantum computing going to solve all of these? Probably not. So quantum computing is not going to replace classical computing. They work hand in hand, but it's going to enhance it. And key will be to find those critical areas where the way a quantum computer works will enhance what you can do classically. A quantum computer works fundamentally different from a classical computer, as you said. Not just in speed, but also how it processes and stores information. So a classical bit can have a value of 0 or 1. A qubit, a quantum bit, can have a value of 0, 1, or a superposition of both. And this concept of superposition, maybe it's difficult to imagine as a human, because this superposition is a mix of 0 and 1s at the same time, allowing you to evaluate simultaneously many possibilities. This is an oversimplification, of course, of how a quantum computer works. But this is also where the quantum computer power lies. It's in handling this complexity and thinking, again, in inverted commas, thinking, is working fundamentally different from a classical computer. So coming back to your question, because I don't want to leave it without an answer, I think that's a personal belief that a chemistry problem, perhaps a molecular design problem, is going to be one of the first to benefit from quantum advantage. And there are a few promising areas of research. They are from other fields, the examples I'm going to give, not from pharma. And the reason is we're working with very small molecular entities at the moment. But everything we learn in this process is going to be applicable to larger molecules, like a proper active pharmaceutical ingredient, or maybe even larger. So, for example, metal organic frameworks for carbon capture. These are lattice-type structures capable of capturing carbon dioxide. That could be one. This is one example. Another example is atomic layer deposition. This is a technology useful for semiconductors, where you're looking to create an atomic layer on top of another material. And then there are the examples that you can see in the media, like battery technologies, catalytic reactions, and many others.
Yeah, and I think the moment we've finished on talking about this, we will have a new method. But this is the thanks for sharing this, Gabriela. So I think this field is super fast moving. There are tons of applications, even in healthcare, which is maybe a bit more complex in itself, which could have even need different approaches to rethink how we formulate problems. But now, I always like to learn from the best. So you are one of the best in this, because it's your job to.
Thank you. Not sure.
Yeah, I mean, we're all the best. Everyone is the best in everything. Not in everything, but everyone is the best in one thing. And this is super fast moving. And as a co-innovator or innovation strategy, talking about innovation strategies, and quantum might even come in leaps, so which makes it even more difficult to catch up, because things just drastically change, and then you have a complete new way where you need to follow papers or need to look at technologies or potentialities. Do you have any strategies, habits, mindsets, daily routines that help you to, let's say, stay innovative or spot promising applications, or are you just playing with it? I mean, it's just something you recommend also for me or other people who move in these fast-moving fields? Is there anything?
It is indeed a fast-evolving field. Yeah, so I think in the end, I can explain what works for me, and people can decide what works for them. Fortunately, I like reading and I like talking to people, so I read a lot every day. I obviously read about advancing quantum technologies and keep up to date with the news. But I also read as much as I can about human biology and psychology, with a focus on what shapes us today, which probably suits the term entangled health, how these changes impact our bodies, what are the consequences. And I discovered, maybe just me who recently discovered, maybe this has been happening for a long time, but I'm part of a growing group of people who want to understand how we can stay healthy over the years, age healthily and happily,
yes, healthy aging,
and build a better society, or at least try to do so.
No.
So, Thomas, you may remember that a couple of years ago, we met again at a conference, and we decided to go for dinner with a few colleagues. And we weren't a big group, a smaller group, but we didn't all know each other. We knew the names, but we didn't meet personally. And we had a very interesting discussion over dinner. We discovered that we all read similar books. We had similar interests.
Yes.
We even talked about creating a book club. So here's an idea for your podcast.
It was over Schnitzel, yeah. Yes,
yeah,
good.
It can be on many topics of interest. It can be lifestyle, diet, physical activities, of course, everything with a quantum spin.
Yeah, and I think this fits. I mean, you mentioned this, so this fits in the Entangled Health, and I think we have even launched last year. So I'm always working in hackathons, because it's super cool just to share a problem and say, okay, I have a problem. I think I have a problem. Well, maybe quantum helps just have students working on this. And one topic we had was also health, exactly this healthy aging, because I think, and it comes then back to your initial question, what is health? and what is aging, and do we want to live forever? Some people want to see they want to be physically immortal. Others want to be just giving their knowledge and have it evolved in other people. But it's another discussion. And I mean, it was really one of the reasons to start the podcast. And maybe I will have this as a last question in future questions, or if we do ask the guests to comment or share. I don't know yet how we want to do this. Maybe setting up a homepage. By the way, you can, or we can have mugs of favorite quotes or favorite limited edition something. So let me, before I think the Entangled Health story, I hoped that is attracting listeners. It's this dopamine session where we start the quantum computing at the random question. But before we do that, you are very big into mentoring, and I think you've emphasized the importance of this quantum literacy for non-experts. And I think during this dinner, you even mentioned that this is a moral obligation. So tell us.
Yeah, so what we talked 2 years ago comes back to haunt me.
Yeah.
No, just kidding. So mentorship, training, and coaching have always been of interest to me. So it's not something new. Mm-hmm. And I read once that the strength of a team is the strength of its weakest link. And it struck a chord. I still remember that. I probably read it 20 years ago. Mm-hmm. Everyone in a team, regardless of the team's purpose, has to be prepared at the same level, of course, if they are expected to work as a team. Mm-hmm. So currently I'm mentoring a group of young scientists in Romania. It's all done in my free time. Mm-hmm. And it's free of charge, of course. Mm-hmm. Sharing from my scientific and business experience. There are other mentors. Most of them are Romanians living abroad. Mm-hmm. We call it the big brain gain, to reverse what used to be the big brain drain, which happened when my generation left the country. Mm-hmm. And I believe it's always important to give something back to society. Yes. Because it's that society who educated and shaped us as the people we are today. Mm-hmm. So if everyone would give something back, the society will become better and will produce better people. I suppose this is what we want, isn't it?
This is true. Yeah. And as you just said, so this is also one of the reasons I'm mentor since, 12 or whatever years in the German Physics Association, also for free, also as a hobby. And it's always good because you're not only you're not only to be the friend or older brother or whatever to young people and say everything you do, it's okay, just walk. You will figure out yourself, but also stay in touch what the needs are of the younger generation and how they approach topics and so on. So it's really cool. So go mentor yourself. If your younger self would ask you for advice about entering quantum space, anything you want to share or something that if you go more philosophical, what would you tell to you? What would you wish that you learned earlier or something?
So imagining what I wish I would learn earlier as a younger version of myself. Mm-hmm. That's the question. Mm-hmm. Yeah. Oh, this is easy. I don't even need to imagine a younger version of myself because I already mentor younger people. So I can see myself my younger version of myself in them.
Wow.
So I've already done this exercise. Okay. And I always tell people to believe in themselves and believe in their knowledge. Mm-hmm. Of course, you'll never know everything, but make your strength what you do know well. Mm-hmm. And this is actually not easy because there will always be people trying to undermine other people. Fortunately, these are a small minority. So it's yourself assessing what you do know well and making your strength. And my other suggestion, I won't call it advice for the reason you mentioned just earlier, that yes, we are a little bit older and we don't want to give advice all the time. So my other suggestion is for women. Don't apologize, even if you haven't done anything. Even if you haven't done anything wrong. So women apologize very often and it comes naturally, but men usually don't for anything. So we should learn from this. And if there is a situation when one should apologize, then apologize. Of course, you need to apologize when you've done something, you feel the need, but only once. Then move on. Everyone makes mistakes. Most of the time is unintentionally. Most of the time they are minor. So this is the lesson I wish I learned early in my career. It took 20 years to sink in.
Yeah, wow. Okay. I just need to give our listeners 1 second to digest this, but it's really cool. So good. Fantastic. So let's maybe just pick up the quantum number generation. So for our friends who know the series well, I will start now the quantum number generator. It will pick a question from our pool. Please contribute with your questions. So currently we have 106. Gabriela will add the number 107. I know, a quick disclaimer, Quantinuum has also a commercially available certified randomness number generator, I think. I only need at the moment 7 qubits because we still don't have a million questions and 1 shot. So it's a quite flat and shallow circuit. So let me just run the thing and then we check which one it picked.
Yeah, we can put a link to the...
we can put a link, yeah, and we will generate...
the quantum randomness for people who are interested in this.
Yeah, and we won't even charge the matching fee. Let's start a machine and look how it listens. Sounds. Wanna go here? Boom. So here it is. Let me just here. It's question number 20. This time it was IBM Sherbrooke, not Brisbane. Cool. So the question reads, Gabriela, take care. If you had a time machine, that is for you. If you had a time machine, what moment in science history would you visit?
Oh, this is so cool. I mean, the way you generate the question is so cool. I mean, my heart stopped for a moment.
Happy to have you live again.
So if I had a time machine, what moment in science history would I visit? Oh, there are so many I would like to see. So this is really a tough question. But looking at my interest, I would probably choose Leonardo da Vinci.
Mm-hmm. Wow.
Because he was a scientist and an artist.
Yes.
And one of my interests...
And a left-handed. Just kidding.
It was left-handed, I'm not, but one of my interests is creative. So I love visual arts. I draw and paint when I had a chance, when I'm not reading.
Wow, okay.
So I would love to be a fly on the wall and listen to his thought process scientifically. And then why did he draw it that way? Why did he paint that way? Understand how he created his work. So yeah, I would love to be somewhere in the shadows, not very visible, and just understand why did he do what he's done and how.
Yeah. So maybe we need to identify how you can at least mentally time travel to different... This is cool. I was not aware that you were drawing, so this is very creative and helps, I guess, also likely when you do these doodles to get cross connections, something like this. So because you answered this, every guest gets of course the opportunity to get can also contribute a question to the random pool, and then of course also can answer it. So, go ahead, please.
So I have a question to ask you. I have the occasion to ask you a really tough question now. Okay, so here we go. If you look back at your decisions you took during your career, is there anything you would change?
Okay. Okay, I think about it. Let's maybe answer it yourself.
Oh, so it's I answer it first. Okay. So thinking back of decision I took during my career, sometimes there were difficult moments, I guess. I think there are difficult moments on anyone's career. So I inevitably ask myself, was this the right thing to do? And the immediate answer could be, maybe I could have done this better if something had happened. But looking back, now I believe that everything contributed to my experience today. Sometimes it did contribute in unexpected ways, so I didn't see it then, but I see it now. So no, in hindsight, I would not change anything. So may I tweak the rules a bit, Thomas?
Yeah,
would you like to answer this question as well?
Yeah. And this is by chance. This is something I'm when I'm walking in the woods. sometimes I'm asking this myself. So what did I, if I would have met my older self, or if I would mentor myself, or what have you, what would I ask? Maybe, or if anything I would change. I think I'm agreeing a bit. I'm agreeing not only a bit. I'm agreeing fully with your answer here. I mean, there are of course situations in hindsight where I have an idea what I could have done in the situation, specifically if I have an argument or somebody was more clever. So I should have made this final pun, or giving a nicer compliment, or being a bit more calm in traffic, or whatever. But on the other hand, I think we are here on running our journey without being too spiritual, but I think we're here to make experiences, and only then, when you touch the hot plate, you can learn it by things. So you learn, believe by experiencing it, and everything is supposed to happen eventually for a purpose. I mean, I'm not the only one who's saying this, and even if it's just to learn that there are things you should never do again, and I think we are sitting here at this moment doing the podcast interview because all happened as it happened. I would not dare change anything, even for this purpose. And just let me tell about my grandma. So she always said, "It is like it is, and it is good." Or quote Voltaire. Eventually, I think it's in Candide, where I think he said, "We live in the best possible world." So I think the most important part in this quote is in the possible world, even though if we want to change things, and world is so complex and entangled. So who would have guessed? I think I just stop talking now. So, but I would not want to know how one specific action turned out in advance, because I think everything, just to repeat myself, happens for a reason. If you try to change the future, we know this movie, Back to the Future, things can go terribly wrong. So yeah, I think if I would ask, maybe I could just ask, is it okay to not to want to know? But then I think I just gave the answer. So it's yeah. Thanks for the opportunity. You put me a bit under.
So you agree with me, I agree with you. So this is the entangled.
Yeah, let's agree with a good. So we're coming to the end, Gabriela, and thanks really for being my guest. And I know we all have a kind of a bit of a busier schedule, and nobody from our bosses called in, so that's good. I like to give you the last word, apart from thanking you being my guest today, and so you have the closing statement. Just go ahead, please.
Well, thank you so much for inviting me to your podcast. It's been amazing to talk to you and, go through all these questions and answers. And it's an amazing conversation. I hope we made it a little bit entertaining too, not too science heavy, but opening the door maybe to new, maybe unusual visions for the audience, because they can dream as well. And I can say that working in this fast evolving quantum computing field in the quantum world, it's absolutely amazing. It's so exciting. And I would encourage everyone to learn a little bit about this. And I'm very happy to share from my experience as well. Thank you, Thomas.
So, dear friends, thanks for listening and entangling to the Entangled Health podcast. Feel free to like it, share it, subscribe on your favorite platform, and if you are inspired, join our guest and submit your question for future guests. Join the conversation either via sending an email, following us on LinkedIn, commenting under the episode. Stay curious, stay connected, and keep exploring the unseen